The 11th question says, which amongst the following metal carbonyls has magnetic property? So there are multiple ways to solve this question. First, we'll try to solve this question with the help of core chemistry concepts. Then we'll just use the basic, the basic chemistry concepts, and we can try to solve this question in a quick go. Okay. First is let's dive into the core chemistry concepts and let's see how we can get to the correct answer. So we have to tell the complex which has a paramagnetic property. So first is nickel is present in zero oxidation state, iron 0, vanadium 0, and chromium is also present in zero oxidation state. Second step is we have to figure out the coordination number 4, 4, 6, and 6. So if we'll try to fill up the electrons in the d orbitals and s orbital, we have to take coordination number also into consideration, because that's how we are going to define the pairing pattern. So we have 3d orbital in all the 4 cases and 4s orbitals. So these are 4s, okay, 3d and 4s. So we have 8 electrons in D and 2 in S in case of nickel, because nickel is actually present in zero oxidation state. So 1, 2, 3, 4, 5, 6, 7, 8, and 2 over here. Okay. Since nickel is actually present in zero oxidation state, so we have overall 10 electrons, and cobalt and like over here carbonyl is a strong field ligand, so it will try to pair up the electrons, right? Okay, carbonyl is a pi accepting ligand, it will try to pair up the electrons. So the pairing is absolutely possible over here. So all electrons would be paired up, and we can say we have 0 unpaired electrons, and if there is no unpaired electrons at all, so it will not show paramagnetic property. The complex would be diamagnetic in nature, right? Let's go to iron. We have 6 in D and 2 in S. Okay. So again, carbonyl is a strong field ligand. It will try to pair up the electrons. Okay. So let's say this will pair up with this. These two will pair up. Okay. And these two electrons will come to d orbital. So basically, it will look something like this. Okay. 1, 2, 3, 4, 5, 6, and then 7, 8. Because the coordination number is 4, so pairing is possible, because over here we'll be getting a vacant d orbital which will actually go into the hybridization process. So we can say over here as well we have no unpaired electrons. Alright, let's go to option C. We have overall 6 electrons, 5 in S and 1 in D. Alright, so we'll try to pair up the electrons because coordination number is 6 actually. So this and this will be paired up. Okay, these two electrons will be paired up, and am I doing some mistake? Yeah, so this is vanadium, right? So unpaired electrons would be different, right? We would be having 3 electrons in D and 2 in S, right? So let's fill up the electrons. 1, 2, 3. Yes, scandium, titanium, vanadium, right? Then we have 2 over here. So if this and this, first of all, there is no need of pairing, you can see, because we already have, you know, two unpaired electrons, so there is no need of pairing at all. But what's going to happen, let's say d s electrons come into the d orbital. So what's going to happen, this one electron will pair up with this one electron will pair up with this, so overall we'll be left with one unpaired electron. That would give rise to the paramagnetic property or paramagnetism. Okay, so we can say yes, we would be having unpaired electrons over here, so the compound would be paramagnetic definitely. Next is chromium, 6 electrons, right? 5 in D and 1 in S. So let's say there's a pairing up. Okay, so there's going to be complete pairing up of the electrons, no unpaired electrons. So we can say option C is the correct answer, because it's only giving you the paramagnetism, and in the question itself you have to tell the paramagnetism complex or paramagnetic complex. All right, so that's how you're going to solve the question. Okay, I have not explained the question into much detail, because this is a easy question. Okay, and we actually solve multiple questions like this pattern, okay, when we just prepare for any competitive examination. So that's how we're going to solve this question. Now let me tell you how you can actually solve this question in a jiffy. Okay, although in TIFR you have sufficient time to solve each and every question, but let's say this question came to your JE jam or net examination, so you can actually solve this question in seconds. Okay, so how you can solve this question? See, if we have zero oxidation state in all the complexes, so total d electrons or total number of electrons would be 10 over here, 8 over here, right, 5 over here, and 6 over here. Okay, so you can see these three complexes have even number of electrons. So since we have like carbonyl, which is a strong field ligand, okay, so if we'll try to pair up the electrons, these three complexes will give you diamagnetic behavior, right? But option C is the only complex where you have odd number of electrons, so this will give you paramagnetic behavior. Okay, so that's how you can dive into the correct answer quickly. Okay, so the correct answer for this question would be option